currently?
Huh?
You're currently a PhD candidate?
Yeah,
too?
PhD candidate, yes.
Excellent, great. All right, take it away.
All right, hello everybody. My name is James Halvorsen. I'm a PhD candidate from Washington State University. And today I'm going to be talking to you about generative machine learning for cybersecurity. I'm going to focus on why this is an important topic for research and in what ways generative machine learning has benefited cybersecurity recently. But before I talk about the generative side of things, I'd like to talk a little bit about why machine learning in cybersecurity. And the answer to all of that is cost. So the number of cyber attacks each year is increasing. We all recognize this. But also, so is the number of targets for cyber attacks. So what I have at the right here is a figure of some 1,200 complaints received by the IC3, that's the Internet Crime Complaint Center, for ransomware attacks in 2023. And you'll note that the list of targets here is quite diverse, with the most targeted organizations being hospitals and healthcare facilities. And because of this diversity of targets, it is possible that any network is a valid target for cyber attackers. And if any network is a valid target, then we can't have every network protected by some dedicated human defender. We need some sort of automated solution. And one of these automated solutions that I'd like to focus on is intrusion detection systems. These are applications that monitor some host or network, and they use the data that they acquire from that monitoring to raise alarms whenever they detect something that could be considered a cyber attack. Now, most of our research related to intrusion detection systems recently is using machine learning in some way. But as we've discovered through that research, there are a few limitations to using intrusion detection systems. One of the big ones is false alarms, where they're misclassifying malicious behavior or misclassifying benign behavior as malicious, right? And the other is a lack of data for both training and testing these systems, which is kind of necessary if you want to do anything with machine learning. And that data problem I kind of need to highlight a bit. So when we deal with data for, say, cybersecurity, we need that data to, first and foremost, be labeled and also have a decent balance between benign data and attack data. And to have those qualities, you need to have human experts creating that data by simulating cyber attacks within some network and then labeling the data that they received. I've actually seen some data sets where they conducted cyber attacks and then didn't label it. So that's kind of a frustration to me as a researcher. That data also needs to be recent, which means that you need to periodically be recreating these new data sets to account for new types of threats. And that data might need to be anonymized if anywhere that data set was collected is dealing with sensitive user information. Okay, so how do generative models fit into all this? What's a generative model in the first place? This is a machine learning model that is trained on some data set to produce data that is within the same statistical distribution as that data set. They take in as input random noise, output new data. And most of the research for generative models is conducted within the last 10 years, believe it or not. This started with the development of variational autoencoders and generative adversarial networks. That figure at the right is actually the training process for a generative adversarial network. So it just has two neural networks, a generator and a discriminator, that are feeding off of each other while the discriminator is trying to see if the data from the generator is too much different from the real samples, and the generator is just taking in noise and spitting out samples for the discriminator to look at. But so far, we've seen a wide variety of applications for generative models. The household names that a lot of you might be familiar with are Stable Diffusion and ChatGPT, although we've seen a few other big developments. And, well, some of these developments have, in fact, been in cybersecurity. I recently conducted a survey paper. That's not the paper I published with you guys, but it's happened around the same time that I got this published, that was dealing with intrusion detection and generative models. And I found that there was like 3 main use cases for generative models related to intrusion detection. These are penetration testing, helping with data sets, right? And using generative models as intrusion detection systems. And this bubble chart I've got here is showing like different types of generative models and how frequently they are used for each of these 3 different tasks. One of the smaller categories there is just other generative models. That is because almost all of the research is surrounding those GANs and VAEs, and very little has been using LLMs and diffusion models and other the recent innovations so far. So one of the more interesting use cases here is penetration testing, right? So generative models can produce synthetic data, and you can use that to create synthetic attacks, one of which being a false data injection attack, which are particularly interesting when you're using them in the context of like SCADA networks and whatnot. But they can also be used to learn from some IDS what types of attacks are going to get around that IDS. I'm also noting that there is some emerging research dealing with LLMs where they're able to craft actual exploit code. This was from one paper thus far, so we still don't know the full capabilities of them. But this was able to craft exploit code that was used in the CTF competition. And this might be making it easier for future cyber criminals to get into cyber crime. So hopefully this is not something that can be used that way, but we do need more research on this topic. My interest in this subject mainly comes around the second application, though, which is balancing IDS datasets. And here generative models are being used similar to a technique called synthetic minority oversampling technique, or SMOTE, where we're generating data that is for some minority class within a data set, right? And we're adding the new synthetic data to the data set so that it has a more balanced range of values, right? And we test that using a metric called train on synthetic, test on real. This table over here at the right is from some of my research that's still underway dealing with a particular type of generative model called DDIMs. And I'll note that when data is balanced in this way, it does have the ability to perform better for classifiers than the original unbalanced data set. So that Sarhan et al. Is the original data set, and those values at the right are my synthetic using binary class and multi-class accuracy. But there's some limitations, like you can't produce a data set from nothing, so you still need some data. And finally, there's the generative models as IDS's approach. This is usually using GAN and VAEs because they tend to use multiple neural networks together. GANs, you can use the discriminator as a classifier. VAEs, the way you do anomaly detection is to use the encoder and decoder together and compute a reconstruction error. So if that ends up too far away from what is statistically likely to be in that data set, it can be considered an anomaly. And thus far, from my survey, I've found that all but one of the papers, when compared to traditional classifier models, will beat out on most metrics, and a third of them are able to beat out classifier models on every metric. So they may be some of the better IDSs out there. So what are some future applications of generative models? Well, I'm thinking that large language models are probably going to play a significant role in the future, primarily because they are able to process text-based security data, and that is one of the more common types of data that you will tend to deal with. And they also have the potential for offering diagnostics after an attack. So if you can receive a natural language description of what went wrong, that can make it easier to recover. I'm also seeing a potential for threat actors to make more offensive utility out of generative models, though I don't know what the extent that is going to be. And finally, I'm also seeing the generative model as IDS approach to be more common simply because they have a higher classification performance. So that may beat out our existing classifiers. Something also worth highlighting is with regards to LLMs, there are tools that are able to self-improve those LLMs, namely AutoGPT. So that may be something worth paying attention to if you wanted to create a cyber weapon that is very powerful in theory. You would want something that is able to not only understand how to create code, but also how to improve itself. All right, summary. There are many use cases for generative models in cybersecurity. And in every single one of these use cases, we are able to achieve some higher level performance compared to what we were dealing with before. And of note, large language models are the model to pay the most attention to because they are both recent and having the most potential for impact in the future. Any questions? Yes.
You mentioned the lack of resources in order to teach each program how to keep labels in order to do the next step. Have you considered, instead of gathering the databases post exploitation or after network has been infected, maybe go towards the malware and actually analyze that portion and see capabilities, creating the tables then, so that you can catch it before it happened? Because there's a repository for malware bazaar and VICEROY that you can find a lot of samples there.
Yeah, you can find some examples of malware files, but the question is, we're looking at what types of effects that malware has on a network. So if you're looking at something like a NetFlow record, right, that's telling you what the network traffic looked like. So you would need to run that malware within a network, and then you would need to put labels to each of those records. Say this was associated with the malware, this was associated with our background data, and whatnot. All right. Who else?
I think we're going to have to cut questions if there. Just want to remind everybody we've got a longer form of the